Getting the desired products from any distillation system depends on being able to operate the system properly. Part of an operator's responsibility is to know how to start up and shut down the system. In a distillation system, a liquid mixture is separated into two or more components by partially vaporizing the mixture and then separately recovering the vapor and the remaining liquid. We can review the distillation process by examining the layout of the system used as an example in this program. The system is a continuous vacuum distillation system that separates a binary feed mixture, which is a mixture of two components. Here's a simplified flow diagram of the system. The mixture to be distilled is contained in this feed tank. In this system, the feed mixture is pumped from the tank to a preheater, where its temperature is raised close to the boiling point of the lighter component in the mixture. The mixture then flows into the distillation column, where vaporization occurs and the two components of the mixture separate. The heavier, higher boiling component collects at the bottom of the column as a liquid. Part of that liquid is circulated through a reboiler and back into the column. Circulating the liquid through the reboiler heats the liquid, which in turn provides heat to the column to help vaporize the mixture. Bottom's liquid that's been distilled enough to meet specifications is drawn off through a takeoff line. This liquid is known as the bottom's product. Meanwhile, the lighter, lower boiling component of the feed mixture rises to the top of the column as a vapor. It's routed to a condenser, where it's cooled and turned back into a liquid. The condensed liquid collects in a tank called a receiver. Part of the liquid, known as reflux, is pumped back to the top of the column. The liquid that's been distilled enough to meet specifications is called overhead product. It's pumped to an overhead product storage tank. Now, we said that this is a vacuum distillation system. Maintaining a vacuum in the column causes the feed mixture to boil at a lower temperature, which reduces the risk of decomposing the bottom's product. The vacuum for this system is created by a pair of steam jets. They draw air and other non-condensable gases from the condenser. The steam from the jets is condensed in these two condensers and collected in a condensate hot well, while the air and non-condensable gases leave the system through a vent line. Before a distillation system is started up, certain pre-startup checks should be made to ensure that the system is ready for operation. To illustrate typical pre-startup checks, we'll use a vacuum distillation system that separates a binary feed mixture. But these types of procedures can vary, so the ones we'll see should not be substituted for the specific procedures used in your plant. Here's the system we'll be using. It's being started up after a long shutdown period. To begin the pre-startup checks, a field operator closes a plug valve under the overhead product tank to prevent any loss of overhead product during startup. Then he selects a reboiler pump to circulate the bottom's product later on. This diagram only shows one pump. Most systems, however, have two pumps. Once the operator chooses the pump, he closes the drain valve and opens the suction and discharge valves for that pump. This procedure is known as lining up the valves. He also lines up the valves for the standby pump according to operating guidelines. He then starts the pump that he's chosen for a moment to make sure that it's operational. In the next step, the operator closes the steam trap drain for the reboiler to prevent steam from escaping later on. Then he opens an isolation valve in the reboiler steam line. A control valve in the line will be used later to admit steam to the reboiler. The next pre-startup checks involve selecting a reflux pump and then a feed pump, following the same basic procedures that were used with the reboiler pump. As before, this diagram only shows one of each pump. Most systems have two of each. An operator in the control room does this by checking a level indicator on the control board. To complete the feed system checks, the outside operator opens an isolation valve in the preheater steam line. A control valve will be used later to admit steam to the preheater. The next steps involve the vacuum system. First, the outside operator opens a valve to supply cooling water to the overhead vapor condenser, and one to supply cooling water to the vacuum system condensers. Then the inside operator checks the level in the hot well, which is a tank that receives condensate from the vacuum system. The hot well level is important because the liquid in the hot well acts as a seal to prevent air from being sucked back into the vacuum system. The two operators then complete the pre-startup by confirming that all of the necessary checks have been made. After the equipment in a distillation system has been readied for operation, the startup of the system can begin. To demonstrate typical cold startup procedures, we'll use a vacuum distillation system that separates a non-combustible binary feed mixture. Now, if a combustible mixture were being distilled, a precautionary step called purging would have to be performed before allowing the feed mixture to enter the column. Purging involves introducing steam, nitrogen, or carbon dioxide into a column to displace any oxygen that's present and reduce the risk of an explosion. Since no purging is necessary for this system, the operators begin the steps to move feed mixture into the column. First, a field operator starts the feed pump. At the same time, a control room operator sets a flow controller to open a valve in the feed line. This allows the mixture to enter the column. When the mixture in the column reaches a specified level, the operator closes the valve by moving the flow controller set point to 0. Since no mixture is flowing from the feed tank to the column, the feed pump needs to be turned off to prevent it from overheating. Next, before the mixture in the bottom of the column is heated, the vacuum system is started up. In this system, 2 steam jets are used to maintain the vacuum. The operator starts the jet that's farther from the column first by slowly opening a valve, which admits steam to the jet and gradually warms the vacuum system. Once pressure in the column drops, he opens the valve for the other steam jet in the same manner. When the vacuum in the column reaches the specified amount, preparations can be made to heat the mixture and begin the distillation process. In this system, the first thing that's done is to start the reboiler circulating pump. Starting the reboiler pump moves mixture from the bottom of the column, through the reboiler, and back into the column. Filling the reboiler with circulating mixture prevents it from being damaged when heat is applied. When the level in the column drops, the outside operator starts the feed pump. The feed control valve can then be opened as needed to feed the column. To ensure that the feed flowing to the column is heated properly, a control valve in the preheater steam line is gradually opened to bring the preheater up to operating temperature. At this point, heat can be applied to the mixture in the reboiler. To do this, a temperature controller is used to open a steam valve to the reboiler. As the reboiler warms up, it transfers heat to the circulating mixture. The heat added in the reboiler and the vacuum maintained in the column causes some of the mixture in the column to vaporize. The vapor from the top of the column is condensed in the overhead condenser. When the condensed vapor reaches a predetermined level in the receiver, the reflux pump is started, and a temperature controller is used to open a valve in the reflux line. All of the condensed overhead vapor then flows to the column as reflux. At this point in the startup, vapor is rising up the column and liquid is flowing down the column. For product separation to proceed efficiently, a specific range of pressures and temperatures must be maintained in the column. Column pressure is regulated by a controller that opens and closes a bleed valve in the vacuum line. Column temperatures are adjusted by regulating either the reflux rate, the boil-up rate, or both. The reflux rate is the rate at which reflux is pumped to the column. It's adjusted using a control valve in the reflux line. The boil-up rate is controlled by adjusting the steam flow to the reboiler. Once column pressures and temperatures are close to specifications, overhead product and bottoms product can be taken off. Ordinarily, the product that reaches the desired purity first is the one that's taken off first. In this case, it's the overhead product. To prepare for the overhead product takeoff, an isolation valve on the takeoff line is opened. Then, when the overhead product collecting in the receiver reaches a predetermined level, a level controller at the receiver automatically opens an overhead product takeoff valve. An overhead product flows to the storage tank. Now, when the bottoms product reaches its desired purity, it too can be taken off. To begin the bottoms product takeoff, an isolation valve in the takeoff line is opened. Then, when the level in the column reaches a specified value, a level controller automatically opens the takeoff valve, and bottoms product is pumped through the takeoff line. At this point in the procedure, there's a continuous flow of product out of the column, and there's a continuous flow of feed into the column. However, the rates of flow may be below the design values for the system. By gradually increasing the feed rate, the product takeoff rates will automatically increase as well, and the startup procedure will be complete. The lighter, lower boiling component of the feed mixture rises to the top of the column as a vapor. It's routed to a condenser, where it's cooled and turned back into a liquid. The condensed liquid collects in a tank called a receiver. Part of the liquid, known as reflux, is pumped back to the top of the column. The liquid that's been distilled enough to meet specifications is called overhead product. It's pumped to an overhead product storage tank. The liquid in the hot well acts as a seal to prevent air from being sucked back into the vacuum system. Column temperatures are adjusted by regulating either the reflux rate, the boil-up rate, or both. Sometimes a distillation system needs to be taken out of service and then returned to service after a short period of time, such as when minor repairs are needed. In these situations, a short-term shutdown procedure is used. The basic goals of a short-term shutdown are to stop the flow of feed mixture to the column, stop the takeoff of overhead product, and stop the takeoff of bottoms product. As much of the equipment as possible is kept in operation so that the system can be restarted quickly. To demonstrate typical procedures for a short-term shutdown, we'll use this simplified flow diagram of a vacuum distillation system that separates a binary feed mixture. Keep in mind, though, that the procedures we'll see should not be substituted for the specific procedures used in your plant. In this system, the first steps in the short-term shutdown involve stopping the flow of feed mixture to the column. First, the steam flow to the preheater is shut off to stop the supply of heat for the feed mixture. Then the feed pump is shut off, and the feed control valve is closed to stop the flow of feed to the column. When the level drops past a specified point, a level controller on the receiver automatically closes the overhead product takeoff valve. This stops overhead product from being drawn off and places the system on total reflux. Now, the absence of feed flow to the column also causes the level in the bottom of the column to drop. When the level drops below a specified value, a level controller automatically closes the bottoms product takeoff valve. This causes the remaining bottoms mixture to circulate through the reboiler and back into the column. A temperature controller detects the increase in temperature and automatically reduces the flow of steam to the reboiler. To complete the short-term shutdown and ensure that no product flows from the system, the level controllers that control the takeoff of overhead product and bottoms product are manually set to 0. Then, the isolation valves in the overhead product and bottoms product takeoff lines are closed. While a distillation system sometimes needs to be taken out of service temporarily for repairs, it may also need to be shut down because of an emergency. And in some cases, an emergency shutdown can be similar to a short-term shutdown. For example, some emergencies require only a brief shutdown. Once the problem has been dealt with, the system may be returned to operation. But the basic goal of any emergency shutdown is to reestablish safe operating conditions. This often involves shutting down equipment that could pose hazards if it were allowed to continue running. Backup equipment may need to be left in operation to stabilize conditions. Once conditions have been stabilized, an emergency shutdown will likely involve stopping the flow of feed mixture to the column, stopping the takeoff of overhead product and bottoms product, and possibly shutting off the reflux system and the vacuum system. Procedures such as draining the column in the reboiler are avoided unless they're needed to maintain safe conditions. Of course, problems that can cause an emergency shutdown can vary, so the exact procedures that are followed will depend on the type of emergency. Among the problems that can cause an emergency shutdown are a steam system failure, which could cause a loss of steam to the preheater, the reboiler, or the vacuum system. A failure in the cooling system, which could cause a loss of cooling water. And an electrical system malfunction, which could interrupt power to plant equipment. During an emergency shutdown, it's important to maintain clear communications with plant personnel and to follow company procedures. Following these rules can help ensure the safety of personnel and limit damage to plant equipment, the products being produced, and the environment. When a distillation system is taken out of service with no expectation of restarting it in the near future, such as when extensive maintenance is needed, a long-term shutdown may be required. In a long-term shutdown, all of the equipment is shut off and the system is emptied. In this vacuum distillation system, a long-term shutdown begins with the feed system. First, the steam flow to the preheater is shut off. Then the feed pump is shut off, while the feed control valve is closed. With the flow of feed mixture to the column stopped, the level of overhead product in the receiver drops. When the level drops past a specified point, a level controller on the receiver automatically closes the overhead product takeoff valve. This places the system on total reflux. Stopping the feed flow to the column also causes the level in the bottom of the column to decrease. When the level falls below a specified point, a level controller automatically closes the bottom's product takeoff valve. This causes the remaining bottom's liquid to circulate through the reboiler. To enable that liquid to cool before it's drained from the system, a temperature controller is manually set to close a control valve on the reboiler steam line. An isolation valve in the steam line is closed as well to ensure that no steam reaches the reboiler. The reboiler's circulating pump is left on for now to help cool the liquid and equipment. At this point, there's no feed going into the column, and the overhead and bottoms mixtures are being recirculated. To shut down the reflux system, a temperature controller is reset to close a valve in the reflux line and prevent overhead product from returning to the column. Then, the level controller on the receiver is set to reopen the overhead product takeoff valve so that the product that has collected in the receiver can be pumped to the overhead product storage tank. Once the receiver has emptied, the reflux pump is shut off to complete the shutdown of the reflux system. The next step is to shut down the vacuum system. First, a pressure controller is used to open a bleed valve in the vacuum line to break the vacuum. Then the two steam jets are shut off in the reverse order from the startup sequence. Once the vacuum system has been shut down and the mixture in the bottom of the column has cooled according to procedures, the reboiler pump is shut off. The column and the reboiler can now be drained. Draining the system enables personnel to perform maintenance without coming into contact with processed liquids. It also prevents liquid in the system from freezing and damaging equipment in cold weather. And it prevents the liquid from depositing a residue in the piping that will need to be removed before the system is restarted. The basic goals of a short-term shutdown are to stop the flow of feed mixture to the column, stop the takeoff of overhead product, and stop the takeoff of bottoms product. When a distillation system is taken out of service with no expectation of restarting it in the near future, such as when extensive maintenance is needed, a long-term shutdown may be required. In a long-term shutdown, all of the equipment is shut off and the system is emptied.